All right. It seems like I'm getting a lot of questions on 41, 46, and 51. Do we need to start on any of the early ones? Any questions on 16 and those? I just emailed everything back to you guys, so you might want to check your email. And if you were, good, I posted your grades as well. But I didn't have time to write anything in the emails, saying, if you're good or not. Micah, your hand's up first.
Dr. McBride, I was just going back over the notes that for 4.26 for letter B.
Yep.
Okay, so can you go over the second part? I was able to do the
A given B.
yes.
Okay.
The
What'd
B
you get?
given B. It was 0.61.
You are correct. Okay. Now the second one, it's asking for what's the probability that something is in B given that it's in the complement of B? What do we know about complements? And I'll open it up to anybody.
It's everything but what's indicated.
Correct. So B and the complement of B are opposites. They have no overlap. So if you're asking the probability that something is in B, given that you're in the complement of B, isn't that impossible?
Yes.
Yeah, it's a 0.
Okay.
And then what about the next one? It says, what's the probability that something is not in B, right? That's what the complement of B means, is basically not in B. What's the probability that something is not in B, given that it's in C? Well, if it's in C, it ain't in B. So that's a 100%. That's a 1.
Okay.
Yeah.
I don't know why I made it so much
Well,
harder.
you're not the only one. A lot of people struggle with those, but it's one of those things where if you try and do them with the formulas, it gets messy. But if you just think it through, it makes a little bit more sense.
Okay.
Yeah. Don't feel bad. You're not the only one.
Thank you.
Yep, of course. Cecily.
Hi. Since we are on 4.26,
Yeah.
and I guess I'll ask you offline. I wasn't quite understanding your notation in what you sent back. 426C.
Yes.
The probability of the union of A and B.
Mm-hmm.
I guess I thought that was the probability of A plus the probability of B minus the probability of the intersection of A and B.
Correct.
Okay.
And if you do those numbers, you get.
Well, you struck through my answer, so because that's what I thought I did, but okay.
For some strange reason, I believe you were one of the students that got the correct answer and then subtracted it from 1. The answer should be 0.77, and a lot of you put 0.22. So I don't know what the heck was happening there.
Oh, okay. Well, maybe. Okay, I'm gonna have to go back. So it's the probability of A plus the probability of B minus the probability of the intersection of A and B.
Yeah.
So the intersection of A and B is not okay.
Well, I mean, you can do it that way, right? You can sit there and go, okay, the probability of A, right, is an employee works at the high level. So you just add up all the high level, which is 0.1, 0.15. Exactly. You get 0.63 when you add them all together.
Okay.
And then B falls into the highest extensive form. So that's just 0.04, 0.1, and 0.22, which adds up to 0.36.
Correct. Okay.
And then the intersection of those two is the 0.22, because that's the people that are in the same category. And so you subtract that away and you're left with 0.77.
Oh, I did it in the reverse. Okay.
Yes. Yeah.
Okay. I see where all righty then. I will wait my turn to ask the second question for me then.
Okay. Micah, your hand's still up. Do you have another question?
No, sir, Dr. McBride. I'm sorry I didn't take it down.
That's okay. All right. Cecily, you're up.
Okay. Then my second question was on 4.46.
Yeah, you and everybody else.
Okay. 4.46C.
Yeah.
Of the 20 returned products, 6 or more are defective and not functioning. Okay.
Yep.
So let me, I need to pull up my my chart. So we, oh no, I didn't have a chart for that. Okay. So, okay. The six or more are defective and not properly functioning. Okay, so the defective and not properly functioning are, I'm sorry, somebody keeps texting me, are defective and not, are the 5% that are defective and not repairable, and the 45% that are defective but repairable? Is that our non, I
Well,
guess that's the issue, is not understanding what the not functioning properly.
right. Okay, so it's asking for 6 or more are defective and not functioning properly.
Okay.
So,
Is that the 30?
sorry, go ahead.
Oh, I was going to say, I think I got, so the 35% say functioning properly, and the 15 obviously have no problem. So it would be 50%.
Exactly. So if we go with the rules of the book and the 5% that are defective and not repairable, and then the 45% that are defective but repairable, and the 35% that have small surface scratches but are functioning properly, those 3 categories, according to the book, are all considered defective. But
Correct.
they say they're defective and not functioning. Well, the 35% that have small surface scratches are functioning properly. So those get taken out. And now
Correct.
we're only looking at the other 2. So we should be doing a binomial with n is 20, p is 0.5, and x is 5, because we have to do the CDF. See, we want 6 or more. So we have to do the CDF up to 5. And when we run that, we get this number of 0.0206, blah, blah, blah. And that's the complement of what we're looking for, because we want 6 or more. The CDF of 5 gives us 0 through 5. So if we subtract 0 through 5 from 1, it gives us the remaining 6 and above. So you basically take this number and subtract it from 1, and you get the answer for C.
Okay, so here's my question. If we go back to the code,
Mm-hmm.
and I think that's what I did initially, but then I went back to probability equals 1 minus CDF. Yep. Is that incorrect?
No, that's absolutely fine. That just gives you the correct answer, and you don't have to do any subtraction. But you just got to make sure that your X is the proper X.
Okay, I see what, okay.
Right? Because you need to subtract away the cases 0 through 5. So you have to set your CDF at 5, because you want to be left with just the cases 6 and above.
Okay, I think that's where my logic, okay, I had the logic, except for I was now looking at, I thought by subtracting the 1, that would give us 6 and, okay, 6 and above, but no. Okay, I see, okay, I see
the CDF is still doing the CDF. The 1 minus, all it's doing is doing the math for you.
I get it now. Okay, I see where my error is. All righty, thank
Awesome.
you.
Yep, absolutely.
Okay.
Kim?
Yes, thank you. So can you talk a little bit about, let's see here, 4.26 B?
Sure.
And C.
Okay, so did you come in late?
I did, yeah. I come in right. Actually, I came out in time, but you guys had already started talking about that, I think.
Yeah, sorry. So part B, you just have to, if you want to do it with formulas, you can do it with formulas, or just move this over here so we can see it. What I do with these is I just figure them out. I just count them out, right? So A given B. So that means we're in B, and B is an employee falls into the highest extensive categories. I did this before last time with colors, and I still think that's a good idea, right? So I'm going to make A is going to be this color. So they work at a high capacity. So that's all of these values. And then B is they fall into the highest extensive training. So that's those. And then C, right, has little or no formal training and works below high capacity. So little or no and works below high capacity are those 4 right there.
And that's what I did. I think my problem was
Perfect.
trying to figure out if I'm doing the math right, because it didn't seem right, especially when I did B, the B, I always say it wrong. So when
B
I
in the
did
complement.
B, yeah, complement.
So let's just look at it, you know, without worrying about formulas. A given B means we're living in a B world, right? We only have the green stuff to work from. So this becomes our new total. So we're
Right.
only working in this, and out of this, what's the probability that they're also in A, right? So you basically have 0.22, and then this is your total. So 0.22 over 0.36. And you do that math, and that's how you get 0.611. And that's the answer for that one. And then when we do B given you're not in B, well, if you're not in B, that means you're everything that isn't colored green, right? Because that's the complement of B. If green is B, then not B are these 3 columns over here. So we're given that we're already in here. This is our new total. This is our new, you know, subtotal. We're only looking at these 9 things. Out of those 9 things, what's the good, right? The good is they have to be in B. Well, none of these are in B. So you have 0 over this. This is a 0. This is impossible. How can you be in B given that you're already in its complement?
Right. Okay.
Okay. Now the last one says we're given that we're living in C. So now we're only looking at the yellow stuff. So given the yellow stuff, which one of those 4 things is also not in B? Well, this is B. All of this is not in B. So all 4 of these are not in B. And we get all 4 of those over all 4 of those. And that one becomes a 1.
Got it. Okay. All right. I see what I was doing. I think I mixed that up with C.
Yeah.
So, okay. I was on the right track on that one. Okay. And I'm not sure, you talked a little bit, how about 4.41, if I can jump in and ask another one or wait?
Yeah. Yeah. That was on my list. A lot of people asked about this. So the only hard part about 4.41 is understanding what the English means, because once you get that, it's really simple. What is probability that a customer will recall the center more than 3 times? Well, more than 3 means 4, 5, and 6, right? So
Right.
more than 3, you just have to add up those 3 numbers. It's just that simple.
Okay.
And then for the second one, well, we'll call the center at least 2 times, but less than 5 times. So at least 2, but less than 5 is those.
Okay.
And then the last one says, what proportion of customers who contact the call center will require a supervisor? Well, they require a supervisor if they call back more than 4 times. So more than 4 times is just those 2, and you add those 2 together.
Thank you. That helps a lot, because I was looking at it going, is that too simple?
Yeah, that's what a lot of students think, is that they think it's just too easy, and it's not. That's
I'm going, there's got to be a formula I have to do. So, okay,
Yeah.
thank you.
Can I ask a question about not too simple?
Sure.
While we're on this topic, final project, but for the part, I don't have a second part with the judges, is it just that simple?
It really is.
Okay.
Yeah.
Just
You're literally just
appeal
taking,
versus total, or okay, because I
that's
keep
it.
going like all around with it, and I
Nope.
just was wondering if it's just that simple, like this
It's
one was.
just that simple.
Okay, that helps a lot. Thank you.
Yep. All right. Kofi, your hand's up. What's up?
Yes, I think I submitted a wrong assignment So some of my answers should have not been the ones I sent in, but still I still have some problem understanding why I got this first one wrong. Like the second two of them, I thought I was doing good over
You're talking
total,
about
but
16?
yeah, because I listened well to whatever you said and I followed that, but I still got two of them wrong. I think the
Okay,
B and
well,
C.
so the first one, she'll be Asian and have type O.
Yeah,
So that's simply just this
1.7.
number.
Yeah.
Exactly. Now the second one, probably that a white donor will not have type A. So white donor not have type A means they have to be white, right? And they have to be everything other than A. So it's simply going to be add those three numbers together.
Which I did, and I still got it struck out. So
Well, I might have been in a hurry. It should be 0.599. So if you don't have 0.599, then you just added them wrong.
okay.
Oh, sorry. It's because this is a conditional probability. So you're given that it's white, so it's not just adding those three. I'm sorry. It's you had to add those three and then divide by the grand total of all four of these. Because given that you're white is the conditional probability. So this becomes our new total. So we're not dividing by 100%, we're dividing by this, which is like 80, it's 0.802, so just a little over 80%. And the same thing is going to happen with these other ones, that when it says the probability that an Asian donor will blah, 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 that means that becomes a given condition. So we're now looking at just the Asian donors. That becomes our new total. So we're going to divide by whatever this number is, which ends up being like 4.2%. But amongst those 4.2, the question is, how many of them, right, have type A or type B? So those two. So it's going to be basically 2.2 divided by the 4.2. And that's how you get that one. So these two are both conditional probabilities. It's the way they're worded, it doesn't seem like they're conditional probabilities, but they really are, unfortunately. You know, like this one basically translates to the probability of type A given that they're white, right? And this one is saying the probability of A or B given that they're Asian. This one, this first one, was just saying the probability that they're Asian and, right, type O. So that's just an and. And then down here, what's probably the donor will have neither type A nor type B. That is, again, just a direct one. So all you have to do is add up all of the things that aren't an A and AB. So basically, you add up all the B's and all the O's, right? So this is basically asking what's the probability that they're type O or type, let's see, neither type A or AB, so or B. Or B. And if you think of them that way, it makes it a lot easier than thinking of the verbs, you know, the English words. Does that clear it up for you, Kofi?
Yes, I think in my other document is right there. I think I sent the wrong one too.
Okay.
So I'll
No worries.
correct that. Then I have one other one. I think I have this. Let me check. Okay. Which was struck out. 44. Yeah, 4.46B. Because I had followed one of your videos, but it still struck out. I don't know why. And this was exactly.
Okay, so exactly 6 of the 20 means we're going to do a PDF, right? This is are defective and not repairable. So if they're defective and not repairable, then we're only looking at this 5%. So when we go to SAS, our probability is going to be 5%. We wanted exactly 6, was it?
6, yes.
Yeah, exactly 6. And we now want the PDF instead of the CDF version. If we run that, that's the probability of exactly 6.
That's what I got.
Again, I was in a hurry, so I could have written.
Yeah, because that I was sure I
Yeah.
followed exactly. That was
I'm
what
sorry,
I got.
Kofi.
Then I think there's another one. 4.51A as well.
51A should have been 0.0419.
No, that 0.958.
Yeah. So you basically forgot to subtract it from 1.
Okay. But I thought I'd put in the minus a CDF.
You must have not put the 1 minus in the
Yeah.
in the function.
Okay, we'll do it again then.
Yeah. All right. Does that get it all for you?
Yep.
Okay. All right. Who's next? Kim?
Yeah, can you just show, you went through the 451A. Can you show how you would do that in SAS?
Probability that the firm will have more than 5 sales. Yes. Okay, so we've got A, we're using it as a binomial. So our sample size is 2,500. Our probability is 1 out of 1,000, so 0, 0, 1. And we want the probability of more than 5. So that means we have to do a CDF, and we have to do a CDF of 5. Because if we want more than 5, we don't want 5. We want 6 and above. So if we want 6 and above, we do the CDF of 5, because the CDF is always that number and less. So the CDF of 5 is going to give us 0 through 5. And then if we subtract that from 1, this is going to give us 6 and above.
Okay, that's helpful. I was started down that and I was trying to figure out what the X was and how best to do that. So, okay, thank you.
Yep. Daisha.
Hi. For 4.46A.
46A. Yep. So 446A says all of the 20 return products have some type of problem. Well, only 15% have no problems, right? So some type of problem means all the other things added together. So that's an 85% chance for any one particular one. So for all 20 of them, we just have to do a sample size of 20. Our probability of success is 85, and we want to know what's the probability of all 20 of them, and we want exactly 20 of them, right? So it's a PDF, not a CDF. And we run that, and there's our probability of exactly 20 of them.
Okay, that's what I had. Okay.
Yep.
Thank you.
Yep. Anybody else? Dennis?
Thanks, Dr. McBride. Just switching gears a little bit on the Turnitin, I'm seeming to have some problems with that. I've submitted it, but
I'm glad you brought that up. I want all of you to just put it in a Turnitin, and if it doesn't work, just live your life, because it's just glitching for everybody. There's just it's like 80% of them work and 20% of them don't, and it's just not worth your time. Just turn it in and just walk away.
awesome.
We make that into a probability problem.
Yeah, I guess we could. Yeah, the bottom line is, guys, the only reason why we're doing turn it in is to make sure that you guys aren't doing any kind of plagiarizing. I really don't think any of you are going to do that, so I really think it's kind of a waste of time to do it in turn in anyways. I just do it because the school, kind of makes us do it. Even for those of you that turn it in and then it doesn't seem to work on your end, I still get a report on my end. Like I go in and I still see these colors, right? And green means it's a really super low similarity rate. And then as it gets closer and closer to red, that means there's more and more similarity. But every time I look at anything that is other than green, the only reason why these are ever yellow and orange is because the person has included the question verbiage, right? They actually wrote out the parts of the research article where it says, answer this question or answer that question. And the other thing it always picks up is your references, right? You have a nice little APA citation or bibliography at the end, and every time I go and look at it, it's all highlighted red and turned it in. I'm like, well, yeah, no shit, Sherlock. Somebody else has used that exact same reference, so of course it's going to pick that up. So if you click on it, you can spend the time and you can go in there and you can tell it to ignore this and ignore that, but it's just a big fat waste of my time and yours. So just ignore it. And I don't want to sound glib, but that's that it is what it is. Just do your turn it in and then don't worry about it. If it comes back red, if you can click on it and figure out why it's coming out red, and then turn off things like the bibliography and stuff like that, that's helpful. But I don't even bother looking at anything other than the red ones at this point, because I know the reason why these aren't green is going to be that stuff. And then if a red one shows up, I go and look at it, and every single time, I don't know why I still look, because every single time it's because they put like all of the question verbiage in there and it's picking up all of that, and so it makes it red. So that's why it's crappy. All right, what else? Dennis, still got another question?
Oh, nope, sorry, I forgot to lower my hand.
No worries. Kofi, your hand's back up.
Yep. On the critique, I was trying to find out where exactly I was supposed to post it, because I tried to post mine in the doctoral. This is for the fourth week, but I don't see any other document there, so I was not sure if I'm the first to post or.
I'm sorry. I got distracted. I was reading somebody's comment in the chat. Repeat what you said, Kofi.
I'm asking where exactly are we supposed to post the critique, because I posted mine and I don't see any other document there. So I was wondering
it's in the discussions.
Mm-hmm.
And it should say research article critique.
Yes, I've done, and I see only mine, so I was a bit concerned.
Could be that nobody else has gotten to it. You're in class 4, aren't you?
Yep.
Yeah, class 4 is small. There's only like 4 or 5 of you, I think, in class 4 left. Yeah, so there's not a lot. So if you go to discussions and go to, you're the first one to post there. So you're not in the wrong place. It's just nobody else has gotten around to it yet.
Okay.
Yep. Taiwan, I think you're next.
Yeah, how you doing, Dr. McBride? I did mine turn it in. I haven't received nothing back from them yet.
Yeah.
So.
Don't worry about it. I was just that, and the reason why I got distracted in the last one, I was reading Mindy's comment. She said she submitted 4 help tickets 3 days later, finally came through, and it only picked up my references. So
that is so true. That's probably been the hardest thing I've done in this class, and that's saying a lot.
Yeah. So I apologize, guys. I should have said this more at the beginning. Just turn it in, and then just let it go. Just forget it.
Okay.
Don't worry about it.
Post it to the critique section so everybody.
Yeah, that's what's more important is copy it and paste it to the critique section so everybody can read it, and then go back and comment on 2 of your other classmates' posts. That's all that matters. The turn it in is not going to matter at all. In fact, last semester I deleted the whole turn it in thing, and the only reason why it's back is because people yelled at me. People above my pay grade said, you have to leave the turn it in there. I'm like, all right, fine, I'll put it back.
Okay.
So, yeah. Yep. Jackie.
Question. Hi. Just trying to make sure fully understanding the CDF versus the PDF. So
Yep.
when we use PDF, when we want an exact number, right? Like exactly
Correct.
5.
Exactly.
And CDF is we want more than some kind of number.
Or less
More
than.
I was just going to say, how do we do less than? That was my
Well, a
question.
CDF actually gives us less than as it is.
So the
if
one minus is what's given us more than.
You got it,
And no
exactly.
one minus gives us less than that number.
Less than or equal to that number, yes.
Less than or equal. Okay. Thank you.
You got it. Kim?
Yes. Are you able to do the Poisson approximation in SAS?
Oh yeah, absolutely. Yeah, it's in the code.
Okay, so it's off of the
right here is the Poisson stuff, right? So here's the Poisson PDF, right? And here's the Poisson CDF. So it just depends on, they want us to do a CDF, right, for the last question, because they want a greater than or equal to. So we can go to our code and we can put it down here. And for this one, to do the Poisson stuff, we have to calculate the mean, right?
Okay.
So Poisson wants a number and a mean, and the mean is 2.5 because that's just our sample size of 2,500 times our success rate of 1 out of 1,000, right? So you do that and you get to 2.5. And then they want to know the probability of greater than 5. So if we do a CDF of 5 and do 1 minus it, then that's going to give us the actual answer, right? Because the CDF of 5 gives us 0 through 5, and then we subtract that away, and that gives us everything bigger than 5, right? So greater than 5 is exactly what we get out of this, and we run that, and we see that we get really close to the other one, because the other one was 0.0419, and this is 0.0420, right? So they're darn near identical.
Right.
So it's a really good approximation.
Okay. Yeah, and I guess the part was throwing me is I looked forever trying to find the program 1 and figure out where to put it at.
Oh, okay.
So
Have you figured it out now?
Yeah, I did.
Okay.
I finally figured out, and I'm like, okay, I've wasted my brain power trying to do this. I said,
yeah,
I'm done.
I should mention that more often for people who might come in and look at one of these videos and not have looked at the other things, right? So basically, all you have to do is just open any function, any SAS function from any of the categories. I just chose summary statistics for no reason other than it doesn't put a lot of crap over here. And then if you click on edit, that it leaves that function there, and it creates a new generic program that's just a copy of it. And then you can just go ahead and do this and delete it all. Come on. Delete it all. And then you can start fresh with coding.
Okay.
And that's how we get programs. So for anybody else that's watching this that can't didn't remember from the previous time I showed it, that's how we get them.
Okay. Yeah, 'cause I did find something when I scrolled down. I think at the bottom I was able to do like program 1, and I wasn't sure if it was the right one because I used the edit function on the others. I just didn't pick up that it's the program. So
yeah, the only reason why it's called program 1 is it's the first time I've done it in that session, and now you see I have program 2 because it's the second time I've made a new program in this session. And if I create another one, it'll be program 3 and so on and so forth.
Okay, thank you.
Yep, of course. All right, who else? Okay, well, I think we've gone through just about every homework question, so I think everybody should be able to get 100% and turn this in soon. So with some of our time left, let's just refresh our memory on what else we have to worry about. Well, this week specifically.
My apologies, I couldn't get my mic unmuted.
Okay, go ahead, Montrese. What's up?
I was gonna ask about 4.21a. I guess it may be simple, but maybe I was just misinterpreting. But for A through D, I'm not sure exactly what's going on or if I'm doing it right.
421A, we're just trying to describe this in English. And these symbols mean T1 given W. So now all we have to do is figure out what T1 and W mean, right? Well, T1 has blood type 0, and W means the donor is white. So this just means what's the probability that a random donor will have blood type of O given that they're white. That's what that means. And then to compute it, right, that's part B just wants us to compute it. Well, having type O given that they're white means given that they're white becomes our new grand total. So we're only looking at the white, or sorry, we're only looking at the white column. Or, gosh darn it, the white row. So we're only looking at these 4 groups, all the white people. And out of those white people, how many, right, have type O? That becomes our good. So 36 becomes our good, and all 4 of these becomes our total. So you just put 36 over whatever this total is and do the math, and that becomes the probability of part B. Now, C and D, I'm glad you brought this up because a lot of people kind of got C and D correct, but they really didn't answer the question because it says justify your answer and explain your answer. So you can't just say, no, they're not independent, or no, they're not mutually exclusive. Yes, those are both true, but I respond with why, how, prove it, right? And we've talked about this before. You have to basically prove it by talking about what it means to be independent. If 2 events are independent, that means the probability of each of those things doesn't change whether or not the other one is true or not. So in essence, you basically can say, all right, I can look at these 2 things and one is white and this one is type O blood. If these things are independent, then the probability of anybody having type O blood has to be the exact same probability as having type O blood given that you're white. Because if they were independent, being white or not being white as a given condition should have no bearing on the probability of T. So if we calculate the probability of T when we can be anything, and we look at that, and then we just add up all these things and divide by 100%, right? And that gives us that answer. And then if we look at the probability of having type O blood given that we're white, which we just calculated up here, if those 2 probabilities are different, then they are not independent. And I already told you they're not independent, so ergo, those 2 probabilities better be different. Now, mutually exclusive means that the 2 things cannot occur at the same time. So how do we prove that probabilistically? Well, if 2 things can't occur at the same time, then that means the probability of their intersection must be 0, right? If they're mutually exclusive, like male, female, or, dead and alive, right? Yes and no. These 2 things you can't be the same thing at the same time. Then the probability of the intersection has to be 0, right? What's the probability that someone said yes and no? That's impossible. They said either yes or no, right? So all you have to do is calculate the probability of W and T1. Okay, well, what's the probability of W and T1? Well, that's literally 36%, right? Because being white and having type O blood is 36 out of the whole thing. So because that doesn't equal 0, these things are not mutually exclusive. Okay. Will my resubmitted work be graded with everything else this weekend? Unit 3. Unit 3. Anything that needs to be resubmitted, I don't grade, and I grade on Mondays, right? So anything that is submitted early, I grade early. And this weekend I made you guys turn it in by Tuesday so I could grade it today, and I turned it back to you today because I'm going to be all busy all day Friday, and I can't do it when I normally do it on Fridays and get it back to you. And I didn't want to get it back to you on the weekend and not have enough time for you guys to resubmit it. So that's why I made you do it early this week. If you submit something normally or resubmit something because you submitted it and it had too many mistakes and you have to resubmit it, then that gets graded on Monday like normal. I always grade on Mondays. Okay, what else? Okay, so like I was saying, now that we've covered everything, I believe, please don't forget that you need to post your research articles, and they need to be posted by midnight tomorrow, midnight Eastern time tomorrow. We want all the research critiques posted, so that gives everybody enough time to go back and read them and respond to them. Because in order to get your full grade, right, your research article critique grade, as it says here in the description, you know, you have an initial post, which is worth 100 points, and then you have 2 response posts, which are worth 25 points each. So if you don't respond to anybody, right, an initial post is due on Thursday, right, response roast. They say response or post 1 is due by Friday and 2 is due by Sunday. I don't stick to that. Just get them both done by Sunday. The only reason why we really wanted you to do a response post on Friday is because if you post a question to somebody and you post it on Sunday, you don't give them any time to respond to your question. So it would be nice if you guys could get your first responses done as early as possible, especially if you're going to post a question and not just you know, an observation, because then that gives the person enough time to read your question and respond to it. Because remember, that can be one of your 2 responses. You can either just, you know, post 2 questions or 2, you know, observations on 2 other things, or you can, you know, respond. You can post to somebody and respond to somebody that posted on yours, or if multiple people had posted on yours, you can just respond to all of their questions, right? So you just have to have 2 other posts, and you know, you're good to go. So any questions on that?
Do you have a preference of how long the response has to be?
No, it just needs to be you know,
more than yes or no.
Thank you. Yes, exactly. It has to move this discussion forward, right? It has to be substantive. You know, I'm not looking for Gone with the Wind or War and Peace, you know, length diatribes, but, you know, a couple sentences at least.
Fair enough.
Yep. Okay, so with that in mind, let's take a look forward, right? Because this is week 4. Next week is week 5. All we have is a homework assignment due week 5. There's nothing extra due next week because you want to start working on your final project. So next week you should be working on the homework and the final project. Don't leave the final project all till week 6. That's a bad idea. So get working on that as soon as you finish all your stuff this week if you haven't already done so. Next week's lecture is pretty mild and simple. We're just basically we're expanding our horizons from the discrete probability distributions of the binomial and the Poisson, and we're bringing in the continuous probability distribution of the normal curve, which is basically the backbone of statistics. Every darn thing you're going to do in statistics that is more advanced is basically built on the shoulders of the continuous variable, you know, and the normal curve probability distribution. The idea of a hypothesis test is all based on a continuous variable like the normal curve or the student's t, those kinds of things. Confidence intervals are all based on the normal curve. All of these kind of more advanced statistical analyses that hopefully one day you guys will do, like in 810, comes from that concept. So it's really important that you understand how the normal curve works, how the idea of a continuous random variable works. All that kind of stuff is really important because everything else is built on top of it. And if you don't have a grasp of that, you will never grasp the other concepts because they are all built on that concept. And we will talk about that on Monday. But if you want to work ahead, please, 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 please watch my videos where I talk about the central limit theorem and normal curves and the normal probability distribution. All those things will introduce you very nicely to that concept, and it's a pretty basic concept. So don't be afraid like, oh my God, he's making it sound like it's gonna be so hard to learn. No, it's pretty basic. I just want to make sure that you get a good handle on it. And then I will say this again and again and again between now and the end of the class. We are not presenting our papers. I know it says it, I believe, in the description somewhere down here about, no, it says it somewhere. I think somebody else saw it somewhere. I tried to get rid of it wherever it said it, but you are not presenting your paper. Where is it?
It's in the unit, I'm sorry, in the document, the final project document. Because
when you download this thing.
I apologize. I missed you saying that, and I was freaking out when I read that. So thank you.
Yes, that's why I'm going to say it again and again and again. We are not presenting. Normally what happens, this is what happens, guys, is normally, week 5, we have our meet sessions and we go over the material for week 5 and we talk about, what to do on the research project. During week 5, you're supposed to submit to me via, email, or better yet, I said it would be much nicer if you put it in the week 5 discussions. So if you just go to the Unit 5 doctoral dialogue and post your part 3 idea, right? So in the assignment, in the final project assignment, part 1 is straightforward. You have a data set and you're going to run a bunch of probabilities on it. Part 2 is also straightforward. You got a data set and you compute a bunch of probabilities. Part 3 is where people's heads explode because it's all kind of it's all theory. There's really nothing to part 3. You don't have some numbers, like you don't have a data file for one thing. Part 3 is in the abstract. The idea of part 3 is you're going to make up your own research scenario that involves collecting data, that should involve collecting data that would be continuous data, i.e. something that's measured, not counted, so that it would create a continuous probability distribution like the normal curve. So you can answer similar questions to the ones that we have in the homework. Now in the homework, they give you a bunch of scenarios, and they give you a bunch of continuous random variables, and you have to compute probabilities of the probability that something is less than this, the probability that something is greater than this, the probability that something is in between these two numbers. Well, you basically do the exact same thing in part 3, but instead of doing it on, this scenario that's given to you in the homework, you're supposed to do it on your made up scenario. Well, with that made up scenario, where's the data? Well, you don't have any data. So just all you need to run these questions, all you need to know is what's the mean and what's the standard deviation, and then what's my sample size, for if they're sample size questions. But usually it's just, pick one out of your thing. So you just need the mean and standard deviation. So just make all that up, right? So for instance, like I would say, okay, I'm going to research how much money nerds like myself make selling off their old comic book collections, because we all have these big comic book collections and we think they're going to be worth something someday, and then the harsh reality comes crashing down our heads and we go to sell everything and find out that it ain't worth shit. So I go out and I collect a bunch of data on comic book collections that have been sold in the last 10 years and how much they were worth, right? So what was the average price of a book, and what was the standard deviation, right? And so I do my research, and I come out, and the average price of a book sold was $1.50, and the standard deviation was like 37 cents. Based on that, I can now come up with these questions. What's the probability that if I sell a book at if I pick a book at random, that it's going to be worth less than $1.25, or what's the probability that it's going to be worth more than $2.50, and then what's the probability that it's going to be worth somewhere between 75 cents and $3. Those things would all be continuous random variable questions based on the average and the standard deviation that I came up with, and I could calculate all of those with our lovely normal probability stuff here, where all I would do is I would put in, my mean of $1.50 or whatever I said it was, and my standard deviation of 0.35 or whatever I said it was, and then go with the CDF is always the area to the left of. So if you want to know the probability that it's less than a dollar, $5, then I put 1.05 in here and run a CDF. If I want greater than, $2, I put 2 in here and do 1 minus the CDF. And if I want in between two things, then I have to do the less than the lower end and the less than the upper end, and then subtract the two to get the in-betweens. So it's simple stuff like that. And if you have a TI calculator, it can do in-betweens for you even easier. And if you have, there are other things, but anyways, that's beyond the point. What's important is that you're making all of this up. And so what I need by the end of next week is for you to post your scenario. What is going to be your made up research question? What's going to be the variable, right? What's going to be the data that you're collecting, so that we can verify that it's going to be continuous. That's all we need to do is verify that what you're collecting is going to be continuous level data. And I've said before that it would be nice if you could try to make this research question based on what you're going to be doing your dissertation on. But it could be that whatever you're doing your dissertation on, there aren't any continuous variables involved. And if that's the case, then make it up. Do something stupid like comic book prices like I did, right? Just, you can't use that one because that's mine, damn it. You can't have it. But come up with something other than, yeah, Alice, my wife, I'm sure would love to have a beer with you and complain about me as much as you would like to complain about your husband and his comic book obsession. I should probably, no, I'm not even going to. I should show you, share pictures of my office with you guys, but I don't want to show you how far gone I am. So come up with something, post it no later than Sunday of next week. If it's going to be based on your dissertation and it's there are FERPA issues, or there are just embarrassment issues, or for any reason you just don't want to post it, then you can by all means email it to me. But I just basically need it by the end of next week so that I can sign off and say, yeah, this is good. This would give you a continuous probability distribution, or this isn't continuous, this is discrete, so we're going to have to tweak this a little bit, that kind of thing. So just remember, continuous has to be measured, discrete is counted. So if any of you submit a research question that asks how many blah 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 blah, I am going to reach through this Zoom session and rip your head off, because that is obviously counting, damn it. You can't do how many, right? How many is a count? That's discrete. We have to measure. DC, Michael. DC all the way. Marvel has the greatest movies. DC has the greatest comic books. Plain and simple. No argument. Jackie.
How many years is that?
No.
That's
How
not, 'cause
many is
that's a how
counting?
many.
That's how many is counting. If you want a time period, you have to ask it a different way, because how many years is going to elicit discrete answers.
Counting.
Yeah, they're going to say 5 years, 6 years, 7 years, right? It would have to be how much time has elapsed between blah 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 and blah blah blah, and then that gives them the opportunity to say 5 years, 12 months, blah blah blah. So you could and then if you want it in terms of years, you could make a decimal, right? It would be 7.3527 years, that kind of thing.
Okay. I was confusing myself with that one, because I was Googling it like, is time discrete or continuous? And
time is continuous. Time is continuous. The problem is that time is normally reported discretely.
As a discrete number.
Yeah.
That's what
and
I
it's
was
the
reading.
same with age, right? Age is a continuous variable because your age is a continuous spectrum, right? We're continuously aging, and so we measure our age, but we report our age as a discrete variable, because nobody says, oh, I'm 35 years, 6 months, 2 weeks, 5 days, they just say I'm 35. So everybody reports their age as a discrete variable. So those get tricky, right? Normally statisticians will let that fly, and I'm fine with it too. If your random variable is going to be age or time, fine, we'll let it slide, because it's really kind of, at its core, it's a continuous variable, but you're going to get discrete data. So you'll treat it as a continuous variable when you analyze it. Just know that you're technically, you're not breaking any rules, but you're introducing a level of error into your results that otherwise you would not do if you had something that was in fact truly continuous, both in its build and how it's reported. So people always ask, okay, smart guy, then how the hell do I get people to report their age or a time span in a continuous way? There aren't a lot of ways. You can give them a slider where they can slide it, and it it shows their age in decimals, right? So they can 34 1 so they go, okay, so they can figure out, okay, I'm 35 and a half, so I'm gonna put it at 35.5, or I'm 35.4, right? Give them the opportunity to really, Cecily, you're 6 hours away. Congratulations, happy birthday. That's awesome. So you could do something like that. Then Cecily would be able to take her little slider and she could slide it right up to 48.99999, that kind of thing. So that's one way, but who's going to do that? Usually you don't have sliders. Usually you're making people do surveys on paper.
And if I saw a survey like that, I would think that researcher wasn't very competent. Like, why would you ask that? It would make me second guess their survey if they had a slider.
Exactly.
For my
So
age.
we let people get away with age and time. So you can go ahead and ask for how many years, and I'm not going to make fun of you, but it is technically a discrete question. But it's one of those things we can't do any better. Like, how many years have you been in school? Well, you could say, how long have you been in school? And then you might get people to fill it in with, years and months. Something like that would be a better question. So you're not forcing them to answer in whole years. Don't even say years in the question. Just say, how long have you been a student, right? How long have you been a nurse? How long have you, whatever. So it gives people the opportunity to say, oh, I've been doing this for 3.2 years, So you could get some smart asses like myself who would answer it with decimals, that they wouldn't give you a whole number, but the vast majority of your people would answer with whole numbers. All right, so does that make sense, guys?
Yeah.
All right, questions on that? I should have asked that a better way.
I got a question on part 1, number 1.
Okay. Let me bring it up.
I get that it's asking, so obviously we're making a histogram for each data type and the numerical summary and finding the mean and the standard deviation. So I'm stuck on the verbiage of describe each probability distribution. So is that like use the SAS?
You're going to describe it like you would any other histogram. Oh, this seems to be skewed to the left. Oh, this seems to be skewed to the right. This seems to be, fairly normal shaped. That kind of stuff.
Okay. Some reason I kept thinking like I had to do some kind of SAS code with one of these probabilities or PDFs or CDFs, but I don't know. It just says describe. But,
no. And
in there should just be the histograms.
Yeah, the histograms and the summary statistics.
And an explanation
exactly. Yeah. You could mention, which because they're discrete, right? These are discrete probability distributions. So you're gonna get histograms, but technically they should be bar graphs because there are gaps, right? This is discrete data because it's all of these questions for number 1. They're all counting questions, how many freights and how many people per parish and that kind of thing. So they're all counting questions. So they should be discrete answers. But to get the summary statistics, remember we have to do a weighted mean. So you have to do the weighted mean, and then you have to do the standard deviation. The standard deviation is really tricky with this data, guys. If you run it in SAS, you're going to get one answer, and if you run it in Excel, you're going to get a completely different answer. So it's really strange. I honestly don't know what SAS is doing when it calculates the standard deviation when you use the weighted, right? Because so if you haven't looked at the data, you have 2 variables, right? So let me get my data so I can show you what I'm talking about. The final project part 1, and run that, and my output data. So you have this variable this random variable, families per parish, and the answers could have been 1 through 6. And then these are the associated probabilities with those answers, right? And then you have freights purchased, and they could buy 1 freight, they could buy a freight and a half, 2, 2.5, 3, 3.5, 4. There was no 4.5, and there was no 5.5, so it just goes 4, 5, and 6. And then of course, all of their associated probabilities. So you can see that this is a discrete random variable, right? Because we have a finite number of answers to our variable, and then associated probabilities with them that sum to 1. And the same thing here, number of people in the family. Again, you're counting, right? So it's a discrete because you can't have a fraction of a person in your family, and then probabilities associated with those. So when you run the summary statistics on these, you have to use the probabilities as a weighting variable. So for instance, summary statistics, right? I'm going to go down here, I'm going to pick up the import, right? And my analysis variable is going to be, I can do families per parish, and then I have to weight it, right? And my weight variable down here, I add in the families per parish probability. Now, if I run this, I'll make this big. Oops, too big. That is the proper mean, but I have no idea what the hell that standard deviation is, because it is not the right standard deviation.
That
at
helps,
least
because I did that in SAS and I got that, and I initially was trying to do it and I was going to try Excel for everything, and I'm like, it's different. So then I'm like, I don't know.
yeah.
It should have been easy. Just click run standard deviation and okay.
Because the standard
I
deviation
got the
for a discrete
593 for there, but
yeah, if you do a standard deviation for a discrete random variable is actually a fairly easy process to do, especially in Excel.
yeah.
And if you
Okay.
do it, you're going to get a huge difference, right? So for instance, this is families per parish. So
Yeah,
yeah,
so
so
then
there's
I
my
was like, well, I don't know which one's right.
yeah,
Why
so
are
the
they
standard
different?
deviation that
Okay.
comes out of, so this is what we get out of SAS, but if you do it in Excel, if you use the actual formula and do it in Excel, you get 1.3274. And that should be the right answer, because damn it, that's what you get when you use the actual formula for calculating a standard deviation of a probability distribution. I have no idea what SAS is doing, and I have asked until my face is blue and nobody has given me an answer. So you can get the means out of SAS, but you can't get the standard deviations. You have to do those in Excel. There's just
So
no.
do that in Excel.
Yeah.
Okay, don't
Yeah.
show the one.
And then, quite
Okay.
frankly, if you're going to do them in Excel, you kind of have to do the mean anyways to do it. So you might as well just do the means in
do it
Excel. Exactly.
Okay.
So I would just avoid doing the summary stats in SAS for this part of the, for part 1. It's not worth your headaches. So I'm glad you brought that up. Yeah, because that's a good one. So back to what we need to do right next week. We got to get all your stuff in by Sunday of next week, so I can say whether or not it's good. If you and then the week 6, normally what happens in week 6 is we don't have any meet sessions because we don't have any new material to go over. So what we do in our meet sessions instead is that's when you present your projects. Well, I don't want to sit on a Zoom session and have you guys present your project. That's a big fat waste of everybody's time. So that's why we're not presenting our projects, and we're not having any Zoom meetings in week 6. So next week are our last 2 Zoom meetings. And I will not be reviewing your final projects early. That's right, kiddos. I'm going to cut your apron strings and make you just turn it in. So make sure that you take a look at it, and if you have any questions about it, I'm more than happy to answer your questions next week, most likely on Wednesday, because Monday we'll be doing, kind of the lecture stuff. So make sure you take a look at the first 2 parts, because there's a question in part 1 that none of you will get right unless you ask about it.
The last one.
Number 4. That is right.
Number 4.
That's right.
But you got a video on it, so
I do.
one of
yes.
those weeks. I don't know
Yep.
which one. I've watched probably like 3 or 4 of all those week 5s, but one of them had it.
Yeah. So if you go back and watch the old week 5s, I talk about it every week. So yeah, you can always go back and look at them that way.
I think maybe the 5th time around it'll make sense to me. I got it, but it's still hasn't sunk in yet what I'm actually
Yeah, 4 is
doing,
a tough
but
one. 4 is a really
yeah.
tough question.
Mhm.
Okay, awesome, guys. Another great session as always with you all. I thank you for showing up, and we will see you next Monday.
Thanks, Dr. McBride.
My pleasure. Good night, everyone.
Thank you.
Take care.
Appreciate it.
Bye.
Good night.
Thank you.
Thank
Yep.
you.
Thank you.